So, is U 4?
Let's see. She accelerates constantly from a velocity. Yep.
And then V is 7.5. And 40 is T.
Yeah.
And then we want the distance, which is S, right?
Yeah.
So we look at an equation that has UVT in, which is S equals a half U plus V times T.
Yep.
Then we would do that in the calculator.
U plus V T. And show you working out by subbing these in. Basically writing down what you type into your calculator.
Yeah. I got 230, which would be in meters.
Acceleration.
Okay. So for acceleration, would you need to like rearrange the equation?
No. Well, okay. Yeah.
So we could use V equals U plus AT.
So I would just do V equals U plus AT, and then I would
sub in everything.
Sub in everything, and your calculator can take care of it.
Okay.
Yeah, and use X for A.
Yeah.
Go on, give it a go. See how.
Okay. I got X is 0.
That's not right. Did you press equals twice?
Oh no. Oh wait, no, I know I went wrong. It's fine. So I did. Oh wait. 0.09.
Yeah, and you can always, if you need to, if this will work, press answer, and you get it as a fraction. Might make things a little easier. Okay, I think we know what. Yeah, this thing. Come on, man. Here we go. And let's throw. Come on. Why? I need a new laptop. But that, I don't know. Oh, I'm hiding answers, am I? I'm hiding answers. Who knows? All right. Let's see the time taken. I'll just see if any of these are worth doing. They're probably not.
Yeah.
All right, I'm gonna say not. After reaching B, find the Philip. There's something slightly weird about C. Kind of begins from that second half.
Okay. So jump to C.
Yeah.
So are these the accelerations for each? The velocity.
Velocity.
Sorry.
Yeah.
It is the initial velocity.
So what was the? Oh, maybe I could have just gone straight for A. How would you do A?
Okay. So would you need to use a Subaru equation for this?
Mm-hmm.
Okay. So would you do initial velocity, which is 8,
Mm-hmm.
but which is u, and then final velocity would be 6, right? Because you do 8 minus 6. Would that not be right?
Well, B, the velocity is 2. I'm looking at, sorry. Let's just do part A. We don't need to do C, sorry.
Okay.
The thing I'm checking.
So is a 8 initial velocity and 2 final velocity?
Yep.
And the acceleration or deceleration, is it minus 1.5 or would it just be 1.5?
Minus 1.5.
Okay.
Because it's deceleration. That's basically what I was checking. And then you just do T is T, and that would be, yeah, I was just checking that you would make it negative because it's deceleration. Hey, what's going to come there? Let's see, a car moves traffic lights straight with constant acceleration. What is U for this one?
Okay. So is u the initial velocity?
Mm-hmm.
0.
Yes, that's great. Just checking that. Let's see. There's anything you can tell me about the answer to A just by reading the question?
Okay. Would it be negative?
Yeah, that would be a negative answer, and I think we just say the positive. Like, if acceleration is -4, then deceleration is, 4. For this one, go on, what are the 3 things that you know from the question?
Okay. So would the initial velocity be 16 and the final velocity be 0?
Well done. So I was just checking that final velocity will be 0.
Yeah.
Let's see. Particle. Velocity of the particle. Let's see. Is that find the time taken, the distance from A to C. Yeah, that's fine. I think we'll be all right. We'll pick it up later. Basically, there's a little trick in there. You could do A to B, then B to C. If you want the distance from A to C, you can just take the initial velocity at A and the final velocity at C and go about it that way. Just take it as one big journey. You'll be all right. Straight line. Constantly then moves. All right. Let me just see. I think this is a good one. And that's a bit bonkers. That's definitely bonkers. So I think this one's worth doing.
So for this, would you have the acceleration is 1.5 and the initial velocity is 1?
5, initial velocity is 1. Mm-hmm.
And then 12 seconds is the time, or t.
Mm-hmm.
Okay. And then do we sub that into one of the equations?
So you sub that in, yeah, and you get V is 19. Okay, part B.
Okay. And then you do initial velocity, which is 19, final velocity, which is 43, and then time is 10 seconds.
Yes, and what I was checking there is that you would use the V of A as the U of B.
Yeah.
And then, let's see, 2.4, and then C.
Okay. So for this, would you have initial velocity, which is 1, final velocity of 43, and then the time as 22 seconds?
So, you think you would, but actually now I regret saying that, because this is two different this is two different accelerations, and suvat is for constant acceleration, and so if the acceleration changes, then you have to do it in two separate journeys.
Yeah.
I believe, but I think, hang on, I think you probably would do that anyway. Well, let me just think about this. So if C, we said U is 1, V is 43, and what's the time?
22 seconds.
And T equals 22. So I might be wrong, but I think if there's two different ones, you need to do it separately. So the distance from A to B is this, distance from B to C is this, and so you would do them separately. Yeah, different accelerations, and so you have to do them. Suvat is for a constant acceleration. Yeah, do separately. Which you could do. What is this weird stuff? That's weird. I'll check the exam papers if it's come up.
Yeah.
Just to make sure. But in the book exam papers, it's only one question. I'll look into it. So this one, it passes through 3 points with this that I've taken. All right. What's more from A to C is 50 seconds. Fine. Okay. I put them all together, but in total there's 5 different suvat equations.
Yes.
Okay, so this one, let's see, 3 things you know, 1 thing you don't. 1 thing you need.
We know the constant acceleration, or the acceleration is 5.
So
we know the initial velocity, which is 3, and the final velocity, which is 18. We're trying to find the S, which is, S.
And which formula is that?
That you can use. Could you use v squared equals u squared plus 2as?
Yeah. Great. And let me just see this one. V squared is u squared 2a. Yeah, fine. Let's see. This is a bit bigger, I suppose. Particles moving, sure, something constant. All right. Yeah, How about these?
Okay. Okay, so we have S, which is 20, U equals 13, and A equals -4.
That's 13. A equals -4. We want T.
Yeah.
Which one is that?
That would be SU. Would it be S equals UT plus a half AT squared?
Yeah. And so solve this one.
Okay.
So a little extra something to it.
I got 1.04 as the final answer.
And how'd you get that?
I just did it all manually.
And it says times.
Oh.
What's that about?
Oh, that's quadratic equation.
Yeah.
So it would have been... Okay. So would you have simplified it down to x times x squared and then like leave -46 over 13 on both sides? Or something like that.
Make it equal to 0.
Okay. So it'd be x squared.
Yx squared.
Oh no, wait, it would be No, it'd be t squared, sorry.
So I believe minus 2t squared? A half times minus 4 times t squared?
Yeah.
Okay.
Minus 2t squared. And then would you minus 20 on both sides?
Yeah.
Which gives you just minus 20, so it'd be minus 2t squared add 13t, right?
Mm-hmm.
Minus 20 equals 0.
And then?
Put it to the calculator as a quadratic.
Yeah.
I got t is either 1, no, not 1, t is either 4 or t is 5 over 2.
That's right, 2.5. And yeah, quadratic, this one you got 2 answers for, kind of a special one. Let's see, B, the value of t when the particle returns to O. Any idea how we do that one?
What does it mean? Oh, the value of the time.
Yeah, so the time it takes for it to return to O.
Would it be double?
From O to A, might be double. No, hang on. A particle, a straight horizontal line. So you have O at the start.
Yeah.
Towards the point A. So I think it might go like that.
Yeah.
And the point A is here.
Okay.
And so let's call this end, or something like that. This is start. So it's like a racetrack. Okay. How can we get from O to A?
From O to A, you just go on a straight line from O to A.
Sorry, from O to back to O. How do we do that?
You go to O to A and then go round and back.
All right.
To the end.
So we know that to get to A is 2.5 seconds, and then another like 1.5 will bring you to the 4-second mark, and you're at A again. But how do you get the total journey from O back to O?
Would you add like the 1.5 and then the O to A again to the answer?
What I would do is, well, there's 2 ways you could do it. I can call the end B or something. So you could find O to B and double it. That's one way to do it.
Okay.
But what is, like what values would you use for that?
Okay.
So tell me if you get stuck on these.
Okay. So would the acceleration still be minus 4 meters per second squared?
Yeah, constant acceleration of minus 4.
And the initial velocity doesn't change either, does it? So it's still 13.
So U is 13.
So we have S equals 20, U equals 13, A equals minus 4. Wait, no. O to A is 20, you can't use 20. So instead we use T, either 4 or 2.5.
No, because that's not half of the whole thing. We would need to find half of the whole thing and then double it. So anything you know about B? Any value you could use there?
Could you use 0?
What would be 0?
S.
S is 0 when it returns back to where it started.
Okay.
Let me think about this. That's crazy enough to work. that's crazy enough to work. If you said S is 0, I mean,
Yeah.
displacement is 0 at 2 spots. At start O and when it comes back around to O. S is 0, like displacement is 0.
Yeah.
And what are we trying to find? T? Okay.
Yeah.
So that'd be T. And which one would we use?
Okay. Would you use what we used before?
Yep.
We'd use S equals UT plus a half AT squared.
Mm-hmm.
Okay. Okay, so we'd put in S is 0, S 0 equals U, which is 13, and then times T, or 13T, plus a half brackets minus 4, and then T squared, which becomes 0 equals 13T plus a half, and then minus 4T squared.
And so we already have a half times minus 4. Simplify.
Oh, it's minus 2, sorry.
Yeah.
So it'd be 0 equals 13T minus 2T squared.
Mm-hmm.
And then you can put that into the calculator.
So we want to try that one.
Okay. I got T is 13 over 2, or T is 0.
Yeah. So it starts when time is 0. So that's when it's the first one.
Yeah.
And the second one is 6.5 seconds. Yeah. So 4 seconds here, 6.5 seconds there.
Yeah.
Yes. The other way you could do it, the way I don't like to do it, is to do half of the journey and double the answer.
Yeah.
At B, what is V?
V.
Yeah.
0.
Yes. And so what you can do is you can say V is 0 and then double the answer. But I like this one where S is 0 and you get the answer in one go.
Yeah.
I like that. Let's see. I'll probably be able to fit this. Sorry. Cut. Delete. Paste. Put that maybe there. Okay, let's see this one.
Okay.
Is that speed of the car? From A to C, constant acceleration. I think you might be alright with this one.
Yeah.
Okay, so this is a new type of thing. The time between the instants. Right. Alright, any idea how we do this one?
Okay. Okay, so for this, I I only got the deceleration and the initial velocity.
So deceleration.
Minus 2.5.
So A is minus 2.5. Go on.
Initial velocity is 15, right?
Yeah. So T is T. When time is 0, it passes through the origin O. What do you know about when it returns back to the origin O?
It's also 0.
What is 0?
S.
Yep. And so it's just like the previous one. S
Yeah.
is 0, and so it's 0 equals 15t plus a half times minus 2.5 t squared. So it's very similar to that one.
Yeah.
What else was I going to say about it? Yeah, or you could split the journey in half. And there was something else. Nah. Sometimes it helps to do a diagram.
Yeah.
That's all. And whatever. So that's their diagram. Yeah, positive direction. Right, that's 12 seconds. Let's see. All right. What is let's see. I think you're fine, to be honest.
Yeah.
I think it's all right. The difference between the times when P passes through A. So the difference between the times. What's the difference between the times when P passes through A for this one?
What do you mean, like, what's the difference between the times?
So we said it passes through the point A, like that part A, when T is 2.5 seconds and 4 seconds. What is the difference between the times?
Would it be 0?
No. Difference between when it passes A one way and passes A the other way.
So the distance from A to B and then back to A?
Not distance, difference in time.
Difference in time. Oh, it's 4 minus 2.5.
Yep. And so
1.5.
Yep. That's all that's about there.
Right.
So the difference between the times and then the total distance travelled by P. The total distance. How could we get the total distance for this journey?
Okay. So could you just wouldn't it just be like you could just sub the things back into the equation and work out the distance?
What things back into the equation?
Like t equals 12 or 13 over 2 or t equals 0 into a different equation that gives you distance, which is s. So you can use s equals u plus v over 2 times t.
You'll get the answer of 0.
Okay.
It will tell you from start to finish, time is 0. Sorry, distance, well, s is 0.
Yeah.
Why is that?
Because you go from the start back to the start.
Yeah. In these equations, s isn't distance, it's displacement.
Yeah.
So how would you get distance? Any ideas?
So will the distance just be 0?
It's definitely not 0. Like the displacement is 0, but if you went all the way around the track and back, any idea how you can work out
O to A, and then you do O to A and then double it. No, O to B, sorry.
Correct. O to B and then double it.
Yeah.
And so O to B, what are the three things?
Okay, you need initial velocity, which is 13. Finite final velocity is 0. And deceleration, which is -4.
Yeah, great. And the important one I was checking there was v0.
Yeah.
All right. Yeah, the difference. The T. What am I looking at here? Yeah, total distance. All right, this one, two particles this time, and moving along a thing. They both leave. No, they both have different accelerations. Different speed, and different time, moving in the same direction. For the displacements, find the time where the particles meet. All right, this looks juicy. Let's try this.
So do you need two Suvat equations for this?
I think we do. Because we have two different particles, two different accelerations.
Yeah. Okay. So would the acceleration of P be 2 and the acceleration of Q be 3.6?
Yeah.
Speed is not velocity?
It's not, but it might as well be.
Okay, so you say initial velocity of P is 4.
So U is 4.
And then the initial velocity of Q is 3.
So this one is 3.
Okay.
Any idea what this is about?
No.
Let's see. So it says find the value, find an expressions for displacement in terms of t. So that means that we have neither displacement nor time. Yeah. So they just want an expression for it. So we won't get an answer as such. It'll just be like a formula for it.
Okay.
An expression for displacement. So S is S, S is S. And let's see, in terms of t, where t seconds is the time after P passed through A.
Yeah.
As passed through A. So do they mean when they have the same displacement at the same time? They seem to not have the same time. It's like t is equal to t plus 1 or something for the other one.
Yeah.
I better check. A is 2, U is 4, S equals ut. So the way they dealt with this is t equals t minus 1.
Yeah.
Okay, so which equation do you use for that?
Okay. We'd use ut plus half at squared.
Yeah.
So would you do for both p and q, right?
Yeah.
Okay, so for p it would be s equals u, which is for 4t, plus a half of a, which is 2, which is 1,
Yeah.
or just t squared.
Yeah.
And then for q, it would be s equals u, which is for 4t plus
q.
Oh yeah, 3, sorry. 3t plus a half. Or you could just say half of 3.6 is 1.8, so 1.8 t squared. Oh, t minus 1 squared.
Yeah, sorry, right. T minus 1 squared. T minus 1 squared. Let me see. I just want to make sure that that's correct. Oh, they just expanded the bracket. What was it? Oh, we forgot the first one as well. So it's not 3t, it's 3t minus 1.
Okay.
Okay. How about B?
Okay. How do we know when the particles meet?
What do you know about the particles at the point where they meet?
They're moving in the same direction.
Okay. In terms of our equations and stuff, anything we can use?
A quadratic formula.
Like, what do they have in common at the point where they meet?
They've travelled the same distance.
Yep. Therefore, how can we use that?
Therefore, we could just say that we could just put a number in and it'd be the same number.
Right. How can we use that?
We could say s is like 0.
We would say like the s of one is equal to the s of the other.
Okay.
And so how do we use that?
We could make the equations equal each other.
Bingo. And so what would it be?
It would be 4t plus t squared equals 3 brackets t minus 1 plus 1.8 brackets t minus 1 squared.
Well done. You would then fully expand, fully simplify, and calculator, and you would get your answer for t. And then you would use that answer for this one, along with 2 other things. Yep. So you created 2 equations, and then at the point where they meet, they have the same s, and you use that to solve it. That's very common for these. Maybe not initially, but like later particles and stuff, where two particles meet, they must have the same displacement from the same point. Another thing, a lot of the time, is they'll have the same time. So they may have different initial velocities. They may have different final velocities. They may have different current velocity. They may have different acceleration. But something that they will have in common is time. And so if you find the time when one hits the other, you can swap that into the other equation. Like the u of 1 isn't the same as the u of 3. You can't, find that in one and swap it into the other, but the time will be the same. Just like if it's from the same spot, displacement will be the same. Time is more common, comes up more often. More useful, let's say. Let's see this one, the acceleration. Coming in a straight line down 3 checkpoints, PQR. PQ is this distance. QR is this distance. Particle takes 1 hour to travel from each Q. The acceleration from Q to R. We have... Alright, this is a good one. Yeah, how do we do A?
Okay. So for this, would you have S as 13.9?
From P to R, is it?
Yeah.
So P to R, S
13.9
would be 13.9. Okay. What would be T?
2.5 hours.
Okay. There's something else though. What third thing can we get then? I don't see. I don't see.
Initial velocity would be 0.
Is it a straight line? I don't think so. Oh, it might be, but they don't say that it is.
Yeah, it doesn't say she started from rest.
And so, what is values for P to Q?
P to Q, like we got 2.4 as the distance, which is S, and 1.5 as the time, which is T.
So I need to put it into meters, don't I? So that is that, and then the time is 60 minutes, and then in seconds, 3,600 seconds.
Yeah.
We don't know the acceleration, but we want it. And
wait, isn't T 1.5 hours, which would be 90 minutes?
Oh, P to Q is the second half, is it?
Oh, yeah. Wait.
Yeah, 1.5. Yeah. So half an hour is 30 minutes, which is how many seconds? Times it by 60? 1,800. So what is that?
Wait.
5,
We're doing P to Q, right? Which is the first part, which takes 1 hour to travel from P to Q. So what? Yeah, it's 1 hour, isn't it?
What? It keeps changing. Hang on. PQR. Yeah.
That was my mistake, I think. Yeah, it's 3,600.
Okay, G-Daman. Well, I got the second part anyway. So for the second one, it's 5,400.
Yeah.
The S is 11,500 meters. A is what we want.
Yeah.
Let's just see. So they'll have different initial velocities. They'll have different final velocities. So what else is there? We want to find... Oh, so the competition is modeled as a particle. It takes an hour to go P to Q. Oh, but it's just one thing. But no, the... I know. For this first one, might say U is U. No. For the first one, you could say V.
Yeah.
Because in the second one, the V of the first one is the U of the second one.
Yeah, yeah.
Alright, how can we do this?
Okay. So, for the first one, S would be 2,400, and then T is 2,600, A is A, V is V. So for the first one, could we use... So we have... So could you use S equals VT minus a half AT squared?
Yeah.
And would it be S, which is 2,400, equals V, or 3,600 V?
Mm-hmm.
Minus a half A.
Mm-hmm.
Well, minus a half. Would you... Yeah, minus a half 3,600 A squared.
Yes, so minus a half times 3,600 squared A.
And would that be 1,800 squared?
No. Bidmus. Square first, half second. Rely on calculator.
Okay. I got 12,960,000.
12,960,000.
960,000.
Like that?
Yeah.
There you go.
And then you half it.
Oh, then you half it. Why didn't you half it first?
Which is 6,480,000.
80,000. All right. I'm dividing everything by 100. Don't care. Oops.
Okay. So 24 equals 36V minus 648,000. No, 64,800 A.
Whatever. 64800. And I'm sure you could make it even simpler by halving stuff. I won't bother.
Yeah.
What would you do next?
Would you... We've got A and V still in the equation, so... You're minus 24 on both sides.
You would make V the subject. You'll see why in a minute.
So you could just add 64,800 A to both sides.
Yeah.
So with 24 add 64,800 A equals 36 V. And then you divide by... Wait, no. Can you divide by 36 by everything?
Yep.
Okay.
There we go.
Over 36. which is 5,402 over 3 equals v.
Hang on. That you have an a there, so let's not simplify anything.
Okay.
Okay, what do we do with the other equation?
Then for the other one, do we make a the subject?
For the other one, you make u the subject.
Okay.
Or first just to create the equation.
So would you use the same equation as before?
No, because we have u this time.
Alright, okay. So we have STU. I could use S equals UT plus a half AT squared.
Yeah.
Which would be 11,500 equals U, which is U should be U, or 5,400 T. U, sorry, 5,400 U. Plus a half brackets A. No, be a half A brackets 5,400 squared.
You're right. Okay. What is 5,400?
29160000.
And did you have it?
Not yet. So it's halved, which is 145800000.
000. A. Okay. And what do you know about how are these two equations connected?
They both have A in them.
Yeah, we want to keep A though. The connection is the V of the first one is the same as the U of the second one.
Yeah.
And so you could make this one make U the subject just for the sake of clarity. 0, 0,
Okay.
0, 0. Wait, no, sorry, I got rid of the. So you make that the subject. 54. That is equal to U, which is the same as V, and so therefore
They're both equal to each other, so you can make them equal to each other.
they're equal to each other, and then you can
Solve
from there. You could
Yeah.
put it. You could put it in calculator, and I think calculator would get it. Yeah, it would because it's linear. And so that stuff. What do you give yourself? Yeah.
It's pretty easy.
Yeah, that's good. And so continue this next time.
Yeah.
Okay, so we're nearly finished this chapter. We only have one thing more, which is gravity. When it's shot straight up, comes down. Yeah, how's that for you, Adam?
That was great.
And so, any questions for me in general?
No.
All right, well done, Adam. You did great, and I look forward to chatting again next time.
You too. Bye.
Cheers. Take care. Bye bye.